Hello guys, this is the first video for Chemistry 101. So we're going to get started with the first chapter, which is Particulate Nature of Matter. This is a fairly basic chapter which does not really require so much in-depth teaching, but as it is a part of the syllabus, so we're going to look into the areas of the syllabus and learn about it. So in this video we're going to discuss the matter, states of matter, properties of different states, kinetic particle theory, how the states of matter change, and also we're going to discussing heating curve, cooling curve, and diffusion. You can find the timestamps in the description so you can navigate through the video. So starting out, what is matter? Matter is basically a substance which occupies space and has some mass. You already know this. The word substance here is applicable for the element, compound, and mixtures. So as you know that there are three states of matter: solids, liquids, and gases. But the question is why these three states of matter exist. Why there is not only one. The answer to this question is that they exist because of the difference in the strength of interparticle force. The word interparticle will change in future. This is a general term. So this difference in strength of the interparticle force changes the states of matter. If it is stronger, the state of matter would be solid. If it is a little less stronger, it would be liquid. And if it is least stronger, it's weak, very weak, it would result in gases. So these are the three states of matter. Now, arrangement and movement of this particle. So in solids, the particles are very regularly arranged and are very tightly packed. While in liquids, there is irregular arrangement and particles are close but not as close as these in solids. In gases also there is irregular arrangement and particles very far away from each other. And if we talk about the movement, the particles of solid can only vibrate about their fixed positions. While in liquids, there is random movement of particles, and gases also there is random movement of particles. Now, as you can see the table in front of you right now, this is basically a table of the characteristics of different states of matter, but I don't think we need to discuss it. It's a fairly simple thing. You can look at it. Kinetic particle theory. Kinetic particle theory states that every substance is made up of particles which are in state of motion. Also, kinetic energy of a particle is directly proportional to the temperature. So if we increase the temperature, the kinetic energy of the particle will increase. If we decrease the temperature, the kinetic particle energy will decrease. It also states that the interparticle force is inversely proportional to average kinetic energy of the particle. So it may sound confusing, but understand it. When we increase the temperature, the kinetic energy of the particle increases. But at the same time, the interparticle force decreases. In solid states, where it is the strongest interparticle force, there will be the least kinetic energy in its particles. When in gases, where it has least interparticle force, it will have highest kinetic energy. So a substance can change its states by changing from solid to liquid, liquid to gas, or directly from solid to gas or gas to solid. So when we move from solid to liquid, it is melting. When we move back, it is freezing. Liquid to gas, boiling back, condensation. If a substance directly changes from solid to gas, it is called sublimation, and if it changes back from gas to solid, it is called solidification. Sublimation is a process in which a solid is converted directly into gas, and there are some compounds which show this property. For example, ammonium chloride, dry ice, and iodine. Dry ice is carbon dioxide, while iodine, I2. These compounds show this property. So let us talk about the changes of state. For example, if we have a solid substance which increases temperature, what will happen is that its particles will gain more kinetic energy, and as kinetic energy is inversely proportional to the interparticle force, the interparticle force will decrease. And as you know, as interparticle force decreases, the distances between the particles increase, resulting in change of state. For example, it will change from solid to liquid, and if we further keep on increasing the temperature, the kinetic energy will further increase and the interparticle force will further decrease, making it a gas. If we reverse the process, the kinetic energy will decrease, interparticle force will increase, and gas will change into liquid by condensation, and again by further cooling it down, it will change from liquid to solid. That's how it works. There are two types of temperature curves which you can see. They are heating curve and cooling curve. Heating curve is something as you see on the screen. So here, a substance which is solid is being heated. So its temperature increases, and it from O to A temperature is increased. A to B, the temperature stays constant, and both solid and liquid states exist at this point from B to C. It is liquid, C to D, both liquid plus gas, and D onwards it is just gas. The temperature is constant at 2 points, A to B and C to D. Now these points are basically the freezing temperature and the condensation temperature, but you would say that it is a heating curve. So how can freezing and condensation take place? The answer to that is that for every substance, melting temperature and freezing temperature are the same, and boiling temperature and condensation temperatures are the same. So there is no difference between them. Now similar to that is the cooling curve, as you can see in the screen. The temperature remains constant at the point when the change of state is taking place. Now these were fairly basic stuff discussed now. Now we're moving to the very important topic, which is known as the diffusion. So this topic is very important. Many MCQs come from this topic, and it's a very important topic. So let's start with the definition of diffusion. What is diffusion? A random movement of particles from higher to lower concentration is called diffusion. Now this diffusion can take place in a mixture of solid and liquid, a mixture of liquid and liquid, and a mixture of gas and gas. A diffusion between solid and liquid, the solid must be soluble in liquid. For example, if you add sodium chloride to water, which is soluble in the water, and liquid plus liquid, the liquids must be miscible, which means that they must mix into each other. So you cannot use oil and water as they are immiscible liquids. While gases, there is no exception. All the gases can diffuse without any exception. Now diffusion is also an evidence to the fact that all the substances are made up of particles. Now an example of diffusion, you can see that we add potassium magnate into a clear water, and it turns purple. Now one thing is the rate of diffusion, which is that how fast the diffusion is taking place. What are the things which affect rate? We're going to look at that. So rate of diffusion is inversely proportional to MR over AR. What does that mean? It means that if a gas has a higher MR, it will diffuse slower. If it has a lower MR, it will diffuse faster. For example, chlorine Cl2, has an MR of 71. And in comparison to the oxygen, which has an MR of 32, it will diffuse much slower. Chlorine will diffuse slower, while oxygen will diffuse faster. So that also the rate of diffusion is inversely proportional to the density. In case of gases, density is like the MR, you can take MR, liquids we take density. Rate of diffusion is also directly proportional to temperature. As we have discussed earlier, increasing the temperature increases the average kinetic energy of the particles. So if the particles have more kinetic energy, they will move faster and they will diffuse faster. Thanks for watching. If you have any queries, you can leave them down in the description. I will try my best to answer them in the reply, or I will refer to them in my next video. Thanks.